Boa tarde a todos, bem-vindos a mais um webinar da Aliança da Construção Modular. Eu sou o Beda Barroquebas, um dos coordenadores da Aliança Modular, que é uma iniciativa do CIX, que é o Centro de Inovação e Construção Sustentável. Esse é o nosso último webinar de 2021. E para encerrar esse ano, nós hoje temos o prazer de receber o professor Gustav Jansson, da Universidade de Luleå, na Suécia. E ele vai fazer uma apresentação que o título é Swedish Modular Construction, Historical Development and Future Directions. Então, vocês vão perceber a Suécia tem um ambiente muito propício para a construção modular e ele vai dar não só o que está acontecendo lá hoje, mas também algum contexto de como eles chegaram lá. Falando para o professor Gustav, ele é professor associado na divisão de construção industrializada e sustentabilidade na Universidade de Luleå. Ele tem desenvolvido projetos de pesquisa em construção industrializada com foco na digitalização do processo produtivo de projeto e construção. Na universidade, ele também é um gerente de vários projetos de pesquisa na área de fluxo de informação de cadeia de valor e o desenvolvimento da digitalização da construção. Antes de iniciar, eu gostaria de lembrar que essa palestra vai ser feita em inglês. E também nós gostaríamos de agradecer aos nossos parceiros, que são o Departamento de Construção Civil da Poli, USP, o Rubik e o House Impact. Gostaria também de convidar os participantes para enviar suas perguntas pelo chat, que serão respondidas pelo professor após a apresentação. Então, vocês podem fazer a apresentação em inglês ou em português, eu posso ir traduzindo, sem problema nenhum. Gustav, once again, thank you very much for agreeing to being part of our last webinar. I'm very excited to see your presentation, and please, the floor is yours.
Thank you very much, Beda. I'll start the presentation by sharing now. As Beda mentioned before, I am Associate Professor at Luleå University of Technology, and I will guide you through the Swedish modular construction with a focus on the historical development and also some future directions in that case. So this will be for about 40 minutes. I will have that and we have questions after that. This will be the presentation. A little bit facts about Sweden of today, because maybe you don't know some of the facts that we have. And then I go through the history from the beginning of the 19th century, about 1800, until today, about 220 years in that era. And I will also look at some future direction for research and also for the industry, which is really interesting to look at for what we're doing now and what we think is interesting for tomorrow. But first, the facts about Sweden. We are a country high up in the north. We are about 10.4 million living in Sweden. And we live at this area of about 400,000 square kilometers. And I do the comparison to Brazil a little bit, so you see how large this is and how many people who live it. And we have a climate. We spoke about the weather as we do as people, especially up here in the north, because we have a different weather in summer and winter. It's about -8 degrees Celsius in January in average. But if we see my cursor, you can see here up is Luleå. So here is water up, and then Finland comes to the right side of the border. We don't have an average. We have an average of -15 degrees in January. And in summer, it's about 16. And that is quite in average of the whole country. So that's not so much different between the south and the north. But I know today that they have snow down in the south part of Sweden. We have a BNP of 537 billion US dollars. And the interesting that I show those two maps. The left one is from agriculture. And as you see, there is not so much used by the land use in that case. It is in the southern part. We have use for agriculture, and we use wheat, grain, and oats. That's the main part. But you see up here is light green, is less than 5% of the area. And the most people live in this area in the south. We have 9 million lives in this area, and we have 1 million lives in the upper part. So the most of them live near the coast also in our area. But the focus is on in our timber industry. The more green, darker green you have, the better quality it is of the timber production. So we have the best timber because it's slow growing timber up here in the north, and we have also good also in the region of 8 and 7, and also quite good in the region of 5. But as you see, comparing to the other one, it's agriculture that is those areas around this. But this is interesting because we have a tradition of using our timber for making houses. And how do we live then? Yes, we have single family houses, about 2 million. So a lot of us live in what we call villas in single family houses. And we have also rental apartments is about 1.3 million and own apartments about 1 million. And the rest is renting houses and other parts of living also. So that was the facts about Sweden. We start now, go back in history 200 years from now. Our king, the Swedish king Karl XIV Johan, he ordered a prefabricated castle. This was the one. It's standing on an island in the middle of Stockholm. It's called Rosendal Castle. And you can visit that if you are in Stockholm. Djurgården is one island in the middle where you also have the ABBA. You know, the most of us know and maybe like ABBA. And the ABBA museum is there. There's also an old ship there is called Vasa Museum. Another museum also. There you can visit that one around a lot of parks that. He ordered that from an architect, Fredrik Blom. And Fredrik Blom was famous because he made prefabricated homes that could be movable between towns. So that was, we can say he was a pioneer for the modular construction in Sweden. So we go on, and in that time of these years, in the beginning of the 19th century, which is 1800 and until 1850, Sweden was one of the poorest country in Europe. According to, we had kings that liked to have war with our neighbors around us. It was the Russian, it was the Danish people, and it was even our best friend in Finland and Norway. So we were so poor in the beginning of the about 1800, around 2.3 million. And they understood that we have to reform the land and to give families land so they can serve themselves with food and grain and different harvests from the earth. And that was made until 1850. And also the industrialization in Europe was influencing the Swedish country then, from Great Britain and Germany mostly. They came to Sweden to see what money could they do of the mining industry and so on. So they invested a lot of money and also knowledge and innovation to Sweden in that case. But there was a backlash in 1867 and also 1868 with snow and frost in June and July, which is our warmest period. And a lot of people died because they didn't get their harvest and they starved a lot. So around 15,000 just died in those two winters after that. That became a depression of that, and many people went overboard to America, which was a loss, of course, but it was also a win because 200,000 of those Swedish people came back. And they came back with knowledge of industrialization and innovation and influence from other direction of the whole world, which also came to America to find the luck. So by innovations, the schools were organized so everyone had to go to school in the 1850s, and the liberation of export made it possible for the industry in Sweden to grow. And industrialization is known well in the beginning of the 20th century, from 19 to 1930, about ABB, Volvo, SKF, LKAB, Ericsson, etc. You maybe know them because they are global companies today. And at 1930, 6 million were living in Sweden, and half of them were now living in the cities. But that became a problem You see the picture up to the right. The standard was low. Diseases and illness and health and so was not good in the town. So in 1928 there was a political reform called Folkhemmet, a welfare state regulation, that the government financed the support for both development of building industry, but also give people possibilities to buy their own houses. So then the industrialization of prefabrication of timber houses was started by the support of the government. So what we see on the left part here is Enskede outside Stockholm, a garden city it called, because they prefabricated houses with a basement in concrete and a timber structure on top with 2 floors. And a small garden so they can go out to and have some small maybe potatoes and some tomatoes and carrots, and maybe they can farm there. And on the right side you see the prefabricated elements that was transported from the factory onto site where were erected manually in that way. The next step of that was important was in the 60s. It was 1965 until and 10 years from that. 100,000 of homes was decided to be built per year, because we had a problem with not reaching that standard with running warm and hot water, and we don't have toilets in every home. We had to go outside and do that. So that was a goal for that million program that was set, that everyone should have that standard in Sweden, also with kitchens and so on, that was manageable. So standardized work and prefabricated of concrete elements for multi-family houses, as you see on the left picture here. And the use of the crane on site was really important to make it so efficient as possible. Of course, there was a backside of that. It became areas that was not that popular in case they became not that planned so well for that case. But a lot of those areas was really good, well done, from organizing new living for the people in Sweden. And on the right side, we saw an inventory coming out from the factories that it was volumetrical modules that was produced in a factory, already installed with a kitchen and a toilet and so. And that was 1960. The first one went out from the factory in Älvsbyn, which is up near to Luleå where I live. It's 50 kilometers from Luleå. So here you see this type of houses in 1960, Älvsbyhus, and that is the one with a small garage connected to it. So that was a cheap house to build, to buy, and many people did that in Sweden. So Älvsbyhus was a pioneer for the modular, volumetrical modular production. So this was, and today we have 95% is prefabricated timber structures for single family houses. And technically it's about 20 millimeter thick walls and about 300 millimeter roof insulation, which is the standard today to meet the climate condition we have up here in the north, both for the winter, especially for the winter, but also for the summer to keep out the heat also, so we don't have the energy so high for us. So, and production time is about 4 to 8 weeks in factory, and the pace of modules, volumetrical modules, is about 20 to 40 modules per week, and that is a little bit different between different factories. But you see the different flow here. You have the prefabrication, and you see here they are installing a kitchen in that case, and then you transport it on site. And Älvsbyhus is one of the actor on the market, but they have a low range product, we can say. So this is the cheapest one you can have, because they don't have a slab on the ground. They have this concrete frame, and then they put their prefabricated volumetrical module, which also have this floor in timber structure also. And if you see up there, you see the upper floor is not always installed with everything, and that is because families that will start their life, they like to buy a house not so expensive, so they can do it by hand. So if you have one children, very small, you don't need the upper floor, but you can buy this house because your family will grow, and especially your economy maybe also grow by hand. So, and you see on the upper right, the Älvsbyhus, a traditional one. They have an option maybe with one part here on the roof and one goes out. But that is quite traditional how we live in Sweden for this type of timber single houses. Here we see the same production on the right top, the video that robots get some boards and put them on the frame of a wall, in that case, about automation. The knowledge from the single family house industry from the beginning of the 30s and to the 60s and to the 80s and 90s. In the 80s and the 90s, the digitalization for robots was developed. So not this type of robot, but nailing robots and cutting robots was really developed under the 80s and 90s specifically for the single family house. And that knowledge was taken over to the multi-family houses in the 90s, when the restriction of fire regulation was put away, so you can build more than 2 stories. And that was really important, because then you can build just to have the sprinkler system, or you have those boards that are protecting from fire. That was another regulation that came that, and now it's popping up some new developers, and Lindbäcks Bygg is one of them that I have studied a lot, and they started in 1992 to take advantage of that new regulation. And for a factory producing this type of volumetrical modules, it takes about 3 to 4 weeks for one project. And one project could be between, say, 150 or 200 modules, also volumetrical modules, up to 400 or 500. And if you have 400 or 500 modules in the factory, in the project, it takes about maybe 7 or 8 weeks to do that, because you have a pace in your production. And the pace is about 40 to 70 modules per week in each factory. Lindbäcks have up to 70 now. I think it is about between 60 and 70 volumetrical modules per each week. So they have a quite high pace in their factories. So I will not focus so much on the factory equipment and so on. I focus on the design phase, because that is really critically for those house builders. But I have some links. Maybe it is on the chat now, but Beda will serve that with them. You can see that, and then they focus on the factory production. Really good videos that you can look at later on. So for the design phase, it is important to understand what could you predefine. And predefinition have been something that I have been really interested in. How can you lock parameters in your product platform? Scania is a really good example, which is well known for their modularization. And they have increased number of components, press tools, to minimize the assembly lines and assembly time in that case, and also maybe the inventory, but still have variants because of their interfaces and combining those modular objects in that case. Of course, this is a totally different context comparing to construction, especially and house building in cases. So we have to see this with critical eyes on the modularization. But it is interesting to take knowledge of the other industry, how it could be used in our context. So the volumetrical module is central for that. What we see here is 2 different module application, and a modularity application. We have commonality, which is the locked part, and we have variable that is flexible. We start with a commonality that is locked, and I have zoomed in the interface between the floor and the wall connection. And at the same time, it's also between two different modules on top on each other. Those interfaces has to be the same, so it's easy to assemble both in the factory and also on site. But the flexibility is important for in length, width, and height for the architect to meet customer needs and also city plan needs for to making layouts that is, it could be usable for the function that you will have in an apartment. So I will show some example of that usability. Here we have one project that Limbex made for student apartments, and if you see the cursor down here, you have a repetition between the buildings, between 2, 3, 4, and 5. We have a repetition. They are identical, and the first one is almost the same. Maybe they have some odd things in the basement, I think. But there are also repetition between the floor plans, that we had the same layout for each floor plan. So you have a repetition both on buildings and floor plans also, but also on the modules. The volumetrical modules are not the first time because they have a window, but that one and that one is the same, and that one and that one is almost the same, and that one and that one. So we have a repetition of that, and that becomes really good when you have a production. Of course, it lacks maybe on the architectural values in some way. I don't think this house is so attractive in that, but it's a student apartment. It's good for living when you do the studies. And Limbex have been quite good to develop this, and it becomes much more cheaper to put out and also sell, and the client could buy it for a lower price because you have the repetition. Here, another project. Here, the standard has to be a little bit higher. You see staircase here in that, and in this picture, and you also see on the left part, you see the facade with the windows are not a repetition of that. And here, the architect and also the end client and maybe the municipality like to show a nice house in the city center, so it not look like it is standardized. Here we have the window are running over the facade, we can call it, and a possibility to do that even if you have the same platform you use. And it's also important, as closer you get to the city center, it has to fit the city plan, and that is important to have flexible modules, so you don't have standardized houses or standardized modules that only fits to a specific plot of an area. And we can see the layout here also in this case. That's not so much repetition of those modules. We have maybe some mirrored one here, and maybe some is repetition, but these are unique modules for the entire project. And of course it could be repetition in height, but we know the windows are identical, but it fits the production in the factory. You just need to know from the data from your BIM model, what should I do for the specific object, and that is important. Here is another one. It's Boklok. Boklok is a combination of Ikea. Maybe you're familiar with Ikea, that you can buy furniture and so on, and Skanska, which is a construction company in Scandinavia and also in US. They are so they combine their business and have developed this concept. And here they have another approach. They have locked their modules in 8 different. You see them in the bottom here. You have 8 different modules that are locked, and you can combine them in a configuration, so you get apartments. And those blocks you can combine to a longer building that could for housing then to develop with the balcony and also a outer corridor we see here. So this is the same thinking that we had both in the 30s and in the 60s for low cost product, that a single mother with her child have afford to come and buy this type because it's low cost, but it's a full standard with Ikea furniture inside, which is affordable in that case. So that is a product that has focus on the low cost, but with good values for that, with the garden and so on. As I said earlier, the design phase is critical, and I started to study Limbex, which is an industrialized house builder in Sweden. Beda has been there and seen their production. I have done a lot of studies of the design process, because it is really interesting to see how they can improve the support of the design phase before production, because the production pace has increased steady state from a number of years. And for those a design phase, you have to communicate a lot of information between the client and the contractor and between different actors. So you cannot push it too much to be too short. You need it to be handled quite wide. So you need a number of parallel projects in design phase because the production is so short. This was about those activities that was studied in 2007. The green ones is a magnet on a magnet board that was according to plan, and the yellow was not following plan, and the red one was urgent and an alert. You have to do something with that. That was the beginning, and I saw that is not enough. You cannot see the progress of how things is happening by only those three colors. So I study and interview people at in the design organization to understand what type of activities are made in the design process and what task do every type of activity has in that, and what deliveries is made to that. So about 100 activities was identified with a number of task lists for each, and that was mapped up to you can say it's a countdown. You see that from in the top, almost the top, is 20, 19, 18, 17, 16, according to the right. That is weeks before production starts in factory. So they know about here I will do this activity and do the delivery. And by that they know, and they have some small tolerances by 2-3 weeks just before production to handle those variations. But it was important to don't have so much variance to that. And that was one way to manage the progress of the design activities. This was in 2010 how it was looked, and the colors was for different disciplines in that one. Each board in this room, this was the control room. They had these boards around their walls, and they could control and went in there from the beginning weekly, but then it became daily control to see the progress. How are we doing? Are we following the schedule? What deliveries have we left to do, and what task is it? And you see the breakdown up to this colored one, from a phase now to some activities, and activities down to task, what, who, when, do, and how do we do those, and they called standard operation sheets to describe those tasks. This was in a manual way. This was only for the design. It was not transferable to site or to the factory, and it was isolated to the design organization. Now we come over to the 2010 to until today, the digitalization for modularized construction. So in 2016, they transformed these magnetic boards to digital version to handle managing those projects by digital tools, by touch screens, so you can show that for each project and communicate with other people that were on distance or on site or something else. And you could have a number of projects to choose between, because the digitalization is more flexible for that. And they also built in for the safety, S for the safety, K for the quality, and so on for the logistics and for the engineering and management of everything. So This was something that was developed in those years. And here you see the magnetic board in digital version in the same way. What do they do in design then? Yeah, they have to create information for the production. And we saw when we studied that the drawings was not a good way to deliver on in production. We need to use the BIM model in a better way. They have used it for files for the robot, but not much else of that. They use them for CNC codes to use cutting and nailing robots and so on, but not information on in which order should materials be supporting the main flow in the production. But the ID and the information for each object were not at that level in the CAD software. So we saw that we could use some algorithms to put in data so they know where they are. I give an example. We see a stud here in vertical studs in this drawing. It belongs to something. Yes, it belongs to the wall. The stud belongs to the wall, and the wall belongs to the volumetrical module, and the volumetrical module belongs to a floor level, and a floor level belongs to a building, and building belongs to a project. That is one hierarchical level of identification of relation between objects. And that is really important for having as metadata for an object. So you can automate the sequence process for production. So I will demonstrate that with this video. We are now inside the BIM model. It's built up of these modules. We see an apartment part, and now we're backing off. And here you see the whole building. No facade, no balconies, and no roof. Quite ugly, but it explains. Here we go from engineering view to a manufacturing sequence view. By automation, it knows where I'm on the first level. I will be the first one that will be put out in the sequence of production on a module level. And we also see that on an element level, if you say the wall element or the floor element, and also on the combination of components. So which order are each component should be produced, and according to a specific element and to a specific module. By putting in that information by the automation, it was possible to simulate the different flows in the factory. And here we have put in some parameters how to simulate those flows in the factory. Here we have the speed one for how we should look at in the visualization here. And we have a buffer, how much should be a buffer for the wall elements, because they were maybe working too fast sometimes according to the other one, and we cannot regulate that. And now we see we have the wall elements in the middle, we have the floor elements to the left, and the roof elements to the right. And now we see the buffer to the left, and we also see those signs with green and red signs in front, and that is when it's working time at that station. And now it's moving and now working, and then they stop working. And now we have synchronized the movement in that case, but we can also do it individually, and also put in some parameters individually for each station. And by doing that, you can configure the whole flow in the factory from a perspective of takt time and buffers. And that was quite valuable for the industrialized house companies that was in that project. We had eight modularized construction companies in that project. We did the simulation. You also see the metadata to the left, a little bit about the BIM data that is showing. And we visualized this in a virtual reality environment called Unity. We have also tested this in Unreal because it's powerful to see what's happening, not just data sheets that showing numbers. It's really important to understand from a factory production perspective, how could this be simulated in such a way? So this was one way, but we have seen that virtual reality has a good possibility because it's not locked like a CAD software or BIM software with functionality. The virtual reality has full freedom for programming numbers of functions. Here's some more future directions of modularized construction. We have for the last year focused a lot on generative design. Some of you maybe don't know what generative design is, but it is a little bit to generate new solutions or shapes or something. Facades has been quite popular in architecture. We are focused on applicate this to modularized construction for the modules itself. I started with, oh, sorry, let me go back. It's not that go. That is better. Now, yes, so here we see parameters that is the base for the generative design. We are in Grasshopper and Rhino, and this time we have tested Grasshopper and Revit also, but it works on different parts. Then we generate, and you see it comes quite ugly solutions comes out for that. So then you have to narrow down your parameters and restrictions of that, so you get better solutions for your generative design. And here you see it comes to one solution, and then you use some type of platform. In this case, Limbex. We took this was a student project. They took Limbex and then generated those layouts according to their system, and then optimized the layout for that, which was this solution. And what we see, that is 3 floors that we see in the solution, and that is what is done on top of the another building on the right side. So it's 3 floors on top of a existing building, and also some rendering picture down on the outer corridor. So the student project was both for generative design and also visualization, and the visualization here is done by Blender in this case. Another, and this is the last interesting future direction I will present. It is how we can generate work instructions for site work by machine learning. On the left side you see the process, and we have studied Boklok in this case, the process of assembling roof cassettes. So roof cassette montage and also gable montage, but the focus is on the roof cassette montage in this video. The instruction is hard to read when you see this type of lines. By first you do that. Of course it could be some interesting part, but it is more interesting to show this together with the visualization of that. Now it is in Sweden, the first one, but here you see a roof, and with a roof trusses and also some roof cassettes that are already put. The last one has to be cut because it has not the difference that fits to a standard, and we see that it's not following that. So then you put the cross on that one, and then you measure out how far this will be, and then you cut it. So this is a description you have of that in the virtual environment. It is presented by at lab in mobile phone or on a tablet that you can have on site, and then you show also the assembly on the roof cassettes from starting at the top and then put it down to the right angle, and also fastening it to the trusses also. The machine learning part is really interesting because modularized construction companies has done a number of projects before, and they can use those data for how they made them on site and learn by that, by the computer putting that up for the best solution made for those type of from the history. And then it could, by generative design, take advantage of designing the best way of doing it. So you have more solutions that the human brain could suggests. So you have the power of both your brain and also what the computer can handle also in that case. And this is not a sequential assembly way in one way. You have different direction and you have a backbone of different schemas in that case. So that was the last presentation of my in this picture of my presentation. So here are some links that Beda have, I think, shared with you also on the chat, and I think it's for me to stop there in the presentation. Thank you very much for listening.